going to expand these three problems, and I see multiplication, and multiplication is going to turn into what? Addition. And this division sign is going to turn into what? To subtraction. So if I color code this, 1, 2, 3, 4. Don't worry about the base. So I'm going to have log base 4 of 2. Cos, what math operation should I put between the yellow and the orange? Here it's multiplication, so it'll be what? Addition. So plus. And then I'm going to do log base 4 of x. And between the orange and the pink, I see multiplication. So when I expand it, it'll turn what? Addition. That's why I'm writing a plus here. So let's do log base 4 of y. But the difference between the yellow, orange, and the pink is it's in the numerator. The denominator, I want to show this to you. You essentially, sparkly pink pen, is everything in the denominator is going to be in there, but we see division, that'll turn into what? Subtraction. So be careful, you might have to distribute that negative sign. So I have log base 4 of z. So this expression is equal to this expression. Alright, put your finger on one of those colors in which you can simplify or evaluate one more step. Put your finger on it. Show your partner. Give him a head nod. Everyone say a number.
A number.
I want a number in 20 seconds. Ready, set, go. Do it with your partner. Think. If I asked you to evaluate that on your test next week.
What do you eat? The fours right there. Yeah, 4 to 1 box. Box equals 20, 25. It can be a decimal, right?
Alright, so I wrote log base 4 of 2 equals box or x? 4 to the something power, right? Now I'm going from log form to exponential form. 4 to the something power equals 2. Well, one way of solving the problem is making sure they're in the same base. How do you change 4 to have a base of 2? 2 what? 2 squared. So 2 squared times the box equals 2 to the what power? What number's here? Huh?
2.
1. Now, in red, that means that these must be equal. Yes? So 2 box equals 1 divided by 2. The box is equal to what? 1/2. Right? That makes sense. 4 to the 1/2 power equals 2 because 1/2 is what? The square root. So the square root of 4 is 2. So all of the yellow becomes 1/2. So 1/2 plus log base 4x plus log base 4y minus log base 4 of z. That's our answer. That one we just had to do a little bit more work of simplifying. Okay, let's try the next one. Tell your partner how many color highlights do you think I'll use for question number 5. Ready, set, go. Class, count with me. Ready, set, go. 1, 2, and 3. Okay. Partner B, tell partner A, what are the math operations that separate the colors? Ready, set, go.
Yeah.
Class, what do we see? Right here, right here. What do we see? We don't see addition, we see multiplication. So multiplication will turn into addition. Let's do that. So there's a plus. Log base 2 x squared plus log base 2 y. I see division. Division turns into what, class?
Subtraction.
Subtraction. So I put a minus sign here. Log 2 of z. Now, put your finger on the one that needs a little bit more simplifying. Partner B, tell partner A what happens to that problem. So when we expand them, you should never have any exponents. The exponents will now come in front. So let's do that. This comes out here. So my final answer is going to be
2 log base 2 plus.
And the last one. Tell your partner how many colors do you think there's going to be and what math operations. Ready, set, go.
I say 4.
Put the what? I only showed you for that first one because eventually if you have a bunch of stuff in the denominator, you have to distribute that negative sign to each one of those. Does that make sense? Class, show me with your fingers. Show me, show me. How many terms? How many colors? How many colors? How many colors? Yeah. 1, 2, 3. Now you might be asking, we have the natural log. Should I turn that into log base e? Well, just like transformations from exponential to logs to natural logs, the properties of expanding and condensing them are actually the same. So instead of using log, we're just going to use natural log. Class, what do I write here? Natural log of 3. I see multiplication, so that turns into addition. So I'm going to put a plus sign. Class, what goes there? Natural log of y. And then in pink, this is, what math operation do we see? And division turns into subtraction. And what am I going to write? Natural log of, let's turn it into a fractional exponent. Class, what number is there?
1.
Does the 1 go on the top or the bottom?
Top.
Yeah, the numerator. And the denominator is the index, so that is 4. And the last step, we just need to change that one to come in front, right? Natural log of 3 plus the natural log of y minus 1/4 the natural log of x. 3 examples of using the properties of logs and natural logs to expand.